This video takes a look at Module 2, Lesson 6, the distance between two rational numbers. Down here we have pictured a number line, which you'll be using today, as well as a review on what rational numbers are, if you need a little recap. So today you guys are going to justify the distance formula for rational numbers on the number line and use it to calculate the distance between two numbers. You know you have this when you are able to properly apply the distance formula to find the distance between two values on a number line. And our standard is 7NSA1C. Understand subtraction of rational numbers as the additive inverse. We did that in a previous lesson. We're more focused on this second part. Show that the distance between two rational numbers on a number line is the absolute value of their distance, and apply this principle in real-world context. So for number one here, I want you guys to go through and find the distance between these numbers using the number line. So there are 1, 2, 3, 4, I believe there's 6. So go through and find the distance for all 6 of those, and then come back and check the video when you are done. So I'm going to work this column first. You should have got 9 here. If I start at -4 and I'm trying to get to 5, it is 1, 2, 3, 4, 5, 6, 7, 8, 9 units away. All right. -3 and -5 and -3, excuse me, you should have gotten a distance of 2. To get from -5 to -3 is 1, 2 hops. Now moving down 7 to -1 is 8. So if I'm at 7 and I'm trying to go to -1, you would move to the left. 1, 2, 3, 4, 5, 6, 7, 8. All right. Now on this side, you're going to end up getting the same numbers. This is going to be 9. This is going to be 2. And this is going to be 8. Now the question that you should be thinking is, why are these the same even though they're a little bit different? And the reason they ended up being the same, because the endpoints are the same, the distance between the 2 points is the same, okay? The endpoints are equidistant away, all right? Now, we are going to look at another way. Let's just take the distance between -4, or let's just do 7 and 1. Okay? So the distance between 7 and -1. Another way to find these, and you know, sometimes the number line isn't the easiest approach, especially when our numbers get bigger, is to subtract and find the absolute distance. So the rule is written as the absolute value of P minus Q. Okay? So in this case, if we want to use it with 7 and 1, we would have the absolute value of 7 minus -1. Now, 7 minus -1, we know that from previous lessons, 7 minus -1, these back-to-backs make a plus, and we end up getting the absolute value of 7 plus 1, which is 8, and the absolute value of 8 is 8. So, part of what you can do to find distance is you want to find the difference between the numbers. So, you want to find how far apart they are. That's difference. You subtract, and then because distance is always a positive, you take the absolute value. Now, taking a look at exercise 2, I want you to use the number line to find the distance here. And if you also want to challenge yourself, because you'll have time later, but if you want to challenge yourself and also use that distance formula to prove that the distance you got is correct, you can try that. All right, so go through and answer exercise 2, A, B, and C, and then come back and check the video to make sure you did each of those 3 parts correctly. For exercise 2A, you should have got a distance of 8 units. What you see is me hopping using the number line, but you also see up here the distance formula. For B, you should have gotten a distance of 1/2. Once again, you see the hopping, you hop a half unit, and you see the distance formula. For C, you should have gotten 4. Similar thing, you see the number line and the distance formula. Now, what we're going to look at is an example. Find the distance between -3 and 2. And we're going to follow the steps, and we're going to practice the formula a little bit. So, start on an endpoint. So, if we have -3 and 2, I'll just start at the first number, which is -3. Now, I am counting to 2. That is my other endpoint. 1, 2, 3, 4, 5, right? The distance between -3 and 2 is 5. We can just sit there and count the distance between those two integers. But let's try this formula. The absolute value of P minus Q. P being the first integer or number, Q being the second number. So, the absolute value of -3 minus 2. Now, I look at this as -3 and -2, making a -5. If you want to do the keep flip change, it would end up being -3, now plus a -2. That ends up getting the absolute value of -5, which ends up getting 5. And we already know that's the correct answer from when we did our little hop strategy using the number line. Now, the reason these absolute value bars exist when we are finding distance is because the distance between two numbers is always a positive unit amount. So by using those absolute value bars, that's going to guarantee that our answer will always be positive. Now let's take a look at example number 2, which deals with change in elevation versus distance. Distance is positive. Change in elevation or temperature may be positive or negative, depending on whether something is increasing or decreasing. But distance by itself, which is what I just mentioned, is always positive. So let's look at A here. A hiker starts hiking at the beginning of a trail at a point which is 200 feet below sea level. So below sea level is going to tell me that is a negative value. He hikes to a location that is 580 feet above sea level. So that's going to tell me that is a positive. What is the vertical distance between 200 feet below sea level and 580 feet above sea level? So this is asking for the distance. It's not asking for like how did it change. Just asking what is the distance. So we can find the distance by using our distance formula. We can subtract -200 minus the positive 580. And remember, we're taking the absolute value of that to ensure that the answer always ends up being positive. Now, if we do our keep flip change, or we add the inverse, we would have -200 plus the negative. Now that 580 then becomes negative. Okay. -200 plus a -580 is -780. And then the absolute value of -780, or how far -780 is from 0, is 780. So I'm going to write this in a complete sentence because it is a word problem, and that just shows a high level of commitment to quality. The vertical distance is 780 feet. Now, question 2, how should we interpret the 780 feet? That means, what does it mean? It means the hiker hiked 780 feet from a point below sea level to a point above sea level. Okay? Overall, really, it just means that's how much the hiker hiked. The hiker hiked 780 feet. Now, to be more specific, he went from below sea level to above. Part B. After lunch, the hiker hiked back down the trail from a point of elevation which is 580 feet above sea level. So let me mark that maybe about here. It's above sea level, so I went above 0. So that's going to be 580. To the beginning of the trail, which is 200 feet below sea level. So 200 could be maybe down here, and I'm going to mark that as a negative 200 because that number is below 0. Now, the question 1 is asking, what is the vertical distance? So it's asking, what is the distance between 580 and negative 200? Now, really, what I'm thinking is I know it's 580 to get back to 0, and then it's another 200. So I know it's 780. Okay? Basically, what he's doing, because it's after lunch, is he's hiking down this way. Before lunch, he hiked up, and I'll mark this for you guys. So this is after lunch, this arrow, and before lunch, he did this. Okay? So we are kind of taking the, we're going the opposite approach. So I can use the distance formula, but like I said, I know the answer is 780 because it takes 580 to get back to 0, and then it's another 200 feet. That's 780 total. But in order to meet the objective, we're going to practice using this distance formula so we become experts. So we're going to do 580, which is our p-value. That's our initial number. And we are going to subtract the negative 200, because negative 200 is our second value, and we know we need to find the difference, which deals with subtraction. Now, these two negatives back to back will make a positive, so you're basically at 580 plus 200. So that ends up getting the absolute value of 780, which ends up getting 780 because 780 is 780 units away from 0 on a number line. So as a complete sentence here, the vertical distance is 780 feet. Now, if I'm looking at 2 is asking what is the change in elevation, okay? Or how much has it moved over time? Now, change in elevation, change can be positive or negative, depending on whether something has increased or decreased. So, when the hiker hiked from below sea level to above sea level, the change was 780 feet. But when the hiker hiked from above sea level to below sea level, the change was negative 780 feet. Okay? So if we are decreasing in our elevation, that change needs to be represented by a negative value. But if we are hiking up, that change would be represented by a positive value. So that's the difference between change and just distance. Change is going to have maybe a negative component, whereas distance, this deals with how far are two numbers, which is always positive. Okay? So what I want you to do is go through and answer exercises 3 and 4. Make sure you answer all parts of 4. There are 5 parts, of 4. Once you have handled those exercise questions, come back and check the video to make sure you correctly answer them before you head on to the problem set. For exercise 3, there are a lot of possible answers. The answer I ended up picking was -9.5 and 3. Those are 12.5 away on a number line. You can see the number line diagram here. You can also see the utilization of the distance formula to prove that the distance is 12.5. So whatever you ended up picking, whatever two rational numbers you ended up picking, make sure that you have proved your answer to show that the distance is in fact 12.5. Now, for exercise 4A, you should have got 3 units. You had to support your answer using a number line diagram and the distance formula. So to the left here, you see the distance formula. To the right here, you see the number line where it's counting 3 steps. Make sure you have both. Same thing for B, you needed to do both. I used a vertical number line because this question here is discussing temperature, and temperature thermometers are always vertical. So that's just something to get in the habit of. But the change in temperature, the change is a positive 33 because the temperature is rising from -18 to a positive 15. So that is a positive change in temperature. Now that's important because in part C, if the temperature dropped, the answer would be different because the change would be a negative 33 degrees because it is going from a higher value to a lower value. In other words, the temperature is decreasing. That is a negative change. Now for D, the minimum distance is 29 feet. You see once again both the distance formula being utilized here and a number line also being used to show that the distance between these two numbers is in fact 14 or 29, excuse me. For E, you should have got the change being negative 180 because you are going from above sea level to below. That is a negative change. You are decreasing in elevation. You see the distance formula here. You see the number line here. Because elevation is also measured vertically, I used a vertical number line. Now, our lesson summary: to find the distance between two rational numbers on a number line, you can count the number of units, okay? So when we are counting those hops, that is a strategy. But sometimes that strategy isn't useful, especially when the numbers become larger or the numbers become more complicated. That's when we can use this formula. And part of your goal for this lesson, as we mentioned at the beginning, is to be able to use this formula. So this formula just states you subtract your two numbers that you're trying to find the distance in between, and you take the absolute value to ensure that that distance is always positive. Now, if it's asking about change, change can be positive or negative depending on whether you are going up / increasing or whether you're going down or decreasing, okay? So go through, answer these 10 problem set questions. They are very straightforward. And then 11 is going to ask any patterns you see between these problems, these 5 problems on the left and these 5 problems on the right. So try to look and see if you find that pattern and then explain why you think that pattern exists. Once you have done that, that will be it for this problem set. And then you'll be able to check your answers before moving on. 1 through 10 on the problem set should have been pretty straightforward. You can see the answers here. So I don't need to read these to you. You can go through and look at them, make sure you have the correct answers. Now, for 11, the pattern that exists is each problem on the right-hand column has the same answer as the problem across for it. So, for instance, if we just look at 1 and 2, both of the answers are 21. For 7, both of the answers are 9. And that is because you're finding the difference between the opposite numbers as compared to the first column. the difference between opposite numbers is opposite the difference between the original numbers. So the absolute value of opposite numbers are the same. Okay, so that's the key here. You're finding the difference between opposites. Those are going to be equivalent or equal. So if you were able to answer those 10 problem set questions, and hopefully you determine the pattern, but more importantly, if you were able to solve using the distance formula, and you were able to handle some of the previous exercise questions, so maybe exercise 4 here, and you were able, in exercise 3, and you were able to correctly apply the distance formula as mentioned here in the lesson summary, you know you're confident with this lesson, you've mastered it, and you're ready to go forward.